Hey there, we are almost done our second to last video of this lesson or of this unit. We're going to be talking about arc length. This is a little bit different than something like the measure of an arc because the measure of arc is done in degrees. This is arc length. Like imagine if I have taken a circle and I clip it at this in the piece and I lay it out flat and I put it up against a ruler and I want to know what the specific portion is, and we would name it in terms of inches and centimeters and stuff. So we're finding arc length, okay? So that's kind of what I was describing here. So just kind of recalling what an arc is. It's a fraction of the circumference of a circle. Okay, so in this one here, this little portion, arc AB, is a fraction of the circumference. And that portion is related to, this angle here. Okay, so that's our minor arc and major arc, just to kind of review those things. So to find for the arc length of a circle, we are literally going to be kind of comparing that measure out of the whole thing, 360. So each of our lengths of our arcs are directly correlated to some kind of angle that's going on here, and that is a portion out of the whole thing, 360. And just like we just mentioned, the arc length, this little portion here, that green piece, is going to be equal to a portion of the circumference. And the nice thing about this is that they are proportional. So think back to Unit 5 when we created proportions. That's essentially what we're going to be doing here, okay? So we're doing something out of 360 comparing to something out of the circumference. And so when we create our proportions, it's always part the whole. And the whole for the degrees is 360, and the whole for the circle circumference is the entire circumference. Okay? All right, so this is the corollary here. I know this little guy is a little messed up. There we go. Okay, get this little guy written down in here, this proportion down here. So what we're going to do, like I said, is create a proportion because the arc length is a portion of the circumference, and the arc that's made is out of the 360. And so what we're going to be doing is we're going to kind of compare that. So the measure of this arc in degrees out of 360 is equal to the arc length. So that, guys, in terms of linear units out of the circumference. And this is important to get written down here, okay? That this is all in degrees, and this side is linear units. We're never going to crisscross that, okay? So we're going to put everything with out of the degrees in one of our ratios, and the other ratio is going to be all about the circumference. We're going to use linear units, okay? All right, let's go ahead and use that. So I'm going to put this here on the side just so that we can have it to reference as we go. What we're going to do is find the length of the minor arc xy below, and we're going to keep our answers in terms of pi. So the arc is this guy right here, and so we're going to create ourselves the proportion that we see here. It's going to be the measure of arc out of 360. Well, as I can see, the measure of the arc is equal to its central angle. So in this case, it's 45. 360 is not going to change. So it's going to be out of, sorry, 45 out of 360 equals, I don't know the arc length. I'm going to call it L. You don't have to call it L. You can use X if you really want to, but it's out of the circumference. And so I see that the radius here is 6, and the circumference is 2 pi r. If you don't remember that, write that down, but circumference is 2 pi r. So I'm going to take the radius and double it and put a pi on the end. And now I'm going to keep my answers in terms of pi. So now I'm going to start cross multiplying after I've come up with my proportion. So I'm going to do 45 times 12, and when I do that, I'm not going to multiply by pi, okay? I'm just going to do 45 times that 12, and I get 540, and 36 times L, sorry, 360 times L is 360. And so from there, we're going to divide both sides by 360 and simplify the fraction. So 540 over 360 will just simplify to 3 over 2, and we're going to keep the pi there. So this little portion here, this is 3 pi over 2 centimeters long, and that's out the proportional out of the whole entire circumference there. That's how long that little piece is going to be, okay? If you think about it too, 45 from 360, that represents a certain fraction. That is technically I think it's 1/8. Yes, just need to, that was 1/8 of the entire circle there. And so if you took 1/8 of 12 pi, you would see you'd get 3 pi over 2 as well. Okay, so that's kind of what I'm talking about when it's proportional. Okay, if I'm going to get an eighth of a slice of pizza here out of the whole thing, then so is that pizza crust. Okay. All right, let's do another example here. If you'd like to try it on your own at home, go ahead and hit the pause button and see if you can come up with some of these answers. Again, make sure we're keeping it in terms of pi. Okay, so if you tried it, hopefully you did. If not, it's okay. We're going to go ahead and do the same thing. Now we're going to do our minor arc AB. So we're looking at this little guy right here. I can see its central angle is 60 degrees. So in the measure of an arc, it's going to be 60 out of 360. I don't know what the arc length is, so I'm going to call that L. And then the radius is 9, so I double that, and I get 18 pi for my circumference. So once again, I'm going to cross multiply. 60 times 18 is 1080, and then 3060 times L is going to be 360L. And then I'm going to divide both sides by 360, and we end up with 3. Okay, as you can see, I'm not really doing much with my pi there. I'm kind of just dragging along, kind of treat it like it's an x or something, where we don't want to actually multiply it through. So once again, kind of think about this again. Like I said, 60 out of 360, that represents 1/6 of the entire thing, because if you were to simplify this fraction, you see it goes to 1/6. Well, 1/6 of 18 is 3. Okay, so just kind of keep that in mind, that these guys are directly related in that sense. All right, one more time, I'm going to do this problem here with you. If you want to hit the pause button to try it on your own, feel free. But I'm going to do this one to the nearest tenth. So we're actually going to multiply by pi this time, okay? All right, so once again, I see that I want PQR, the major arc, so I'm going off of this angle, this arc out here, which means this is 260 degrees. So in our proportion, it's going to be 260 out of 360, not 100. So make sure you're paying attention to the directions as to which one we're referencing here, okay? All right, I'm just still trying to find the length, so L on top. The radius is 10, so 2 pi r gives me 20 pi. So when I go to multiply, you can do 260 times 20, or you can actually go through with the 5,200 and multiply by pi, you'll get some decimal. Anyways, when we divide, you should end up with 45.4 meters. If you really wanted to keep it in terms of pi, there's nothing wrong with that, but I'm just letting you know that sometimes I might say, yeah, go ahead and round to the nearest tenth, in which case it would be 45.4, but it does not have to be that way, okay? All right, so we've found length in these last couple examples, so now let's kind of look at a couple where we're finding something else, okay? So in this one here, we're finding the measure of the arc RS, so kind of thinking about the proportion. The blank spot is going to be the measure of the arc in terms of degrees, because I give to you the 12.3. So the 12.3 represents the radius, not the diameter, just so you know in this problem. But I am giving you the 38 feet is the length of this little arc right here. So I don't know the circumference. That's why I came up with the circumference right here. If you're ever not sure if I'm giving you radius or diameter, feel free to question that. Okay, I'll let you know. Anyways, so the radius is 12.3 feet. That represents this portion right here. So the circumference is double that, or 24.6 pi. And then I'm telling you the arc length, which is why the top here is 38. Okay. Hope I didn't get you all mixed matched when I switch these guys around. It doesn't really matter which side it's the linear units are on. Just thought I'd switch it up a little bit. Anyways, so let's go ahead and find the measure of the arc, because the unknown is the top of 360. So I cross multiply and then I divide, and I find that the angle there for RQS is going to be 177.1 degrees. Okay, so once again, the unknown piece is the measure, not the length in this one. I'm telling you what the length is, as indicated right here on the outside. Okay, one more example here. We're going to find the circumference and the radius. So the first thing I'm going to do is find the circumference, because that's going to be the easier part. Now keep in mind, when we create our setup here, one of the pieces is the circumference. It's going to be the linear unit side. So if I have 3.44 as indicated by the length right out here, out of the circumference, I don't know what that is, equals 60 out of 360. I do know that angle. So the unknown part is this guy down here, the circumference. Okay, and I don't need to use 2 pi r in there, because I'm actually trying to find out what that measure is. So if I were to cross multiply and divide, I found that the circumference is 20.64. If I had asked you for the radius, well, then the first step would be for you to go through and find the circumference first, and then use that to then find the radius. So I know the circumference is 20.64, and I know circumference formula is 2 pi r. So now pay attention to this next piece here, okay? When I go to solve for r, you have to be really careful, because we have to divide by 2, and we have to divide by pi. So a good thing might be able to convert the 2 times pi into a number, and then divide that. But if you just want to take the 20.64 and divide it by 2 pi, I highly recommend using some parentheses when you do that, because if you just type in divide by 2 pi, you're technically dividing by 2 and then multiplying by pi. So either use parentheses or convert it to decimals right away. Anyways, the radius here is about 3.29. And that's all for our examples here. Okay, go ahead and get started on that practice.